VLSos here. This is a video lesson on the quotient rule for differentiation. Let's take a look at a function y is equal to 3x squared over sine of x. This is a fairly sophisticated function if we're considering wanting to take the derivative of this. It's a rational function. It's a function, a fraction of one function over the other. We could think of the structure of this as a function f divided by a function g. We have pieces that we could label. F is given to the function that's in the numerator, 3x squared. We could take the derivative of f right away, which is 6x. The denominator, the function in the denominator that we're labeling g, is sine of x, and the derivative is cosine x. But the derivative of a rational function is not as simple as a rational function composed of the derivatives. It's a more sophisticated pattern. The derivative of a function divided by another is the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the square of the denominator. This is the property of how to differentiate a rational function. Notice that the numerator is very similar to the product rule for differentiation, but we're not adding. In this case, we're subtracting. So if we have the pieces of the structure of the function, we can use this pattern to find the derivative of y. In this case, it's going to be the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator divided by the denominator squared. This quotient rule is very useful. It's worth committing it to memory.